Okay, I'm just doing a quick screencast on CNC Lathe. Um, this is actually going to be a 4-axis because of the notches. But if you didn't have a 4-axis lathe, you'd have to move this to the mill and do milling like from that point of view there. Like those 3 holes and these 3 notches. So the plan is going to be to machine this side as far as we can go. Then we flip it over and machine this side remaining and the bore and all that. Now if you're in 4-axis lathe, then you can actually get it to start milling that stuff. So let me put it back to the original orientation here. Name view. There we go. Alright. The other thing I'm going to put in is a 3-jaw chuck. Right there. 3-jaw chuck. And material. There's some material there. Alright. Good enough for simulation. I probably would hold it by more than that, but we could probably play around with it. But we can't machine in this area. We've decided we're only going to machine this far. Alright, so this one's actually something I got out of cam sample. So this has already been done. So let's simulate this one. Alright, so there's our stock. Our orientation on CNC lathe would be tools that are upside down and coming from this position. Alright, let's hit play. Machines the front, machines the outside. You can see those multiple cuts there. You have to switch tools. Yeah, switch tools again. That's a finishing tool. And grooving, a little bit of grooving, and then looks like spot drill and drill. Let me move this out of the way. And threading, which probably just blew right by it. There's our threading tool right there, a little teeny little 60-degree tool doing that thread. Alright, so this is done. Now normally, like when we set up the operation here, we close this out. You're putting in like a relative size cylinder or a fixed sized to represent the stock. Oops, go here. And the setup will be Z this way and X that way. So, and in this case, it looked like using the front of the model. And they got a safe zone, stock front. And they got turning on turning. And the stock is a fixed size and turn this stuff on. And let me go through the other operations. So facing is alright, using a what kind of tool is this now? Not sure, I got too many intermingled tools there. Model front. Yeah, retract clearance moves. Step over in computer. Okay. We have the profiling. This is like the roughing one. You can see all the cuts there. Actually, I did not program this. I got this from the CAM samples. Actually, I learned a lot by looking at the CAM samples. I think this actually has the older profile up here. Alright, so this was set up to be a dual chuck, like you put a chuck on this side and hold on to that. Alright, we're holding on to this. This is sort of what you have to imagine. This is all finished, except for those slots. So we're going to hold on to this area here, and not in the radius. The radius is not a clamping area. That would be adequate. Or in a collet, that would work. And you got to have some way to know exactly where this is, because you have to make everything on this side line up with this side. Alright, so I switched to operation 2. I actually saved what they call a stock model, and I had to import it as an STL file. But let me just turn off the chuck and the body. Alright, so there's our material, even with the drilled hole. I was able to save it. And this is actually a better demonstration of operation number 2. So we'll put the chuck back on. And operation is our material. Okay, I'll resume this out a little bit. I'm sorry, I got the wrong one on there. Operation 2, there we go. So in this case, let me just flip this around this way. This is sort of like if we had to do it in our lathe, we would have to flip it over and do a new setup, right? So it'd be Z this way, X that way again. Only we need to have some control of where do we place this. So we'd actually use a soft jaw that was cut. I think actually we could capture it by the outside of this ring right here. That would be the best. Only problem is we can't mill the little slots. So maybe it would have to make a soft jaw with a counter bore so it stops right here. So you can place them in and they still hold it. This is like a universal jaw, so but good enough for demonstration. Let me put, let's see, X is up, that'll be front. Okay. See how the simulation will work. Simulate. Alright, here we go. And hit play, right? Same thing again. You're going to machine the front. And it's not working this time. Remember, this is finished now. You got the rough tool, you got the finish tool, big drill. This is a boring tool. And now, let me stop. This would be, in real simulation, this would be rotating, but at this point it would be stopped. This now becomes a axis. This will become the C axis. C rotates around Z. And this will be the spinning tool. So this is really just like, imagine you're in a milling machine. Now, in our shop, this is how we would have to do it. We'd have to set it up a third time this way. So it's just a round part. Orientation would not matter. And we would mill it in this direction. And that's all really a 4-axis lathe is doing. It's just doing the same thing a mill could do, only just oriented it different. Alright, so this actually was set up to do engraving on the side. So let me go back to the... Now this is the orientation, what they call a sub-spindle. So you'd have a chuck on the left and a chuck on the right. So this is kind of high level. So it's like you could do everything without touching anything. You wouldn't even have to flip it over. If you had a 4-axis, actually it becomes more than 4 axis because this also becomes a axis. So it's like, I think it's like 6 axis. So all right, let me turn. Let's see. Operation 2. Okay, I got to replay this one again. Okay. Zoom up a little bit. All right. There's the boring bar in there. We had the pre-drill. Now it's milling. You know, an end mill milling the slots. Spot drill. Make sure you get enough clearance there. You don't want this to hit that. This looks like a tap, 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 tap. And now it becomes a, in the VF2 we could set this up as a 4th axis part and do 4th axis engraving. So actually what happens is this would be rotating back and forth. But in CAD simulation, that's what it's really doing. Alright, so that's a little engraving tool there. And if you look here, it did this engraving. So when you're getting into this multi-axis world, it's not really any more difficult. I mean, it's a lot of stuff going on. You got the left-hand chuck, and then if you add left-hand chuck with milling, all right. So now you got milling and turning. Then if you have the sub-spindle this side, what happens is this slides over and grabs that. So that'll be controlled as far as where it is. And then you machine this side, you know, do lathe work on this side, turn it into a mill, and then turn it into a simultaneous axis. This is the spinning tool, and to engrave this would have to go. Let's see. In a mill, this would be the Z direction. This is X in the lathe, and Z would be this way, and this would be, I don't know if they call it C2, or the sub spindle would be rotating like this, right, like that. So every time it comes up, it'll be coming up in X, not Z. So just different orientations. So I thought I'd give you a quick little, I thought this is pretty good little simulation of how to do that. And but if you're learning all your basics, you're just applying all your basics to this situation. But if you just even see this operation 2, how are you going to hold it? It's the same problem you have on milling. You got to be able to hold the part after the first operation. Okay, so I'm going to end this one and go to bed.